All right, number 10, we get to graph this cosecant function. So first of all, before we get to the graphing, let's go ahead and do the period, phase shift, and vertical shift. The period is going to be 360 divided by this number in front of the theta. So that's 1/2 theta. So the period is going to be 360 divided by 1/2, which is 720. Remember that the period is always, the typical period is 320 for everything except for tangent and cotangent. Tangent and cotangent, it's 180 that you'll divide by this number. For cosecant, secant, sine, cosine, it's all 360. So 360 divided by 1/2 gives us our period of 720. The phase shift is going to be 315 divided by 1/2, which is 630. And since we're adding, this is going to the left. And then the vertical shift there is none on this. We're not adding or subtracting anything outside the parentheses here. All right, so what I've found is the easiest way to graph these cosecant and secant functions is to first graph the reciprocal function. So let's graph y equals the sine, 2 sine of theta over 2 plus 315. All right, because the cosecant is the reciprocal of sine. So if we graph the sine function, we'll be able to see where the asymptotes are going to be and where the starting points are going to be. All right, so to graph this, first of all, there's no vertical shift, and so the midline is going to be right on the x-axis. And we're shifting 630 degrees to the left. So that's off of our graph. But remember that these are periodic functions, which means that they look exactly the same if you just move over one period. So if it was going to be right on the midline, since it's sine, it would start on the midline. If it was going to be on the midline at negative 630, it's going to be on the midline one period later at negative 630 plus 720, which is just 90. In other words, shifting 630 degrees to the left is the same as shifting 90 degrees to the right. Since these are happening, it's exactly the same every 720 degrees. So let's start right here at 90 degrees. And then after one period, so another 720 degrees, we're going to be back at, and that's going to put us off our graph. We'll be off our graph out here somewhere. And then halfway between those 2 points, so 90 plus 360 is going to put us right here. We'll be at the midline right there as well. And then if we take that 90 minus 360, half a period, that's going to put us here at, did I say 270? This is 450 out here. And then 90 minus 360 is going to put us at negative 270. And the amplitude is 2, so halfway between these 2 points we'll reach our maximum of 2. Halfway between these 2 points we'll reach our minimum of negative 2. So let's see, 1, 2. So right here. And then halfway between these 2 points we'll reach our maximum of 2. Between these 2 points we'll reach our minimum of negative 2. And then the sine function would look like this, right? We can connect all those dots. But we don't really need to, because we're not trying to graph the sine function, we're trying to ultimately graph the cosecant function. So everywhere where we cross the midline, everywhere where we put a dot right on the midline, that's going to be an asymptote for the cosecant function. So we're going to have an asymptote right here at negative 270 degrees. We'll have an asymptote here at 90 degrees. we'll have an asymptote here at, what would that be, 450 degrees. And then right here where we had a minimum, that's going to be a place where our graph is going to start and go down, right at that minimum point. And right here where we had a maximum on our sine function, that's going to be a starting point for this piece of the cosecant function going upward. And then same thing with over here and up here. All I really need to see on the test is you give me at least one full period. So one of these going down, one of these going up. I'm going to be looking to make sure that you got your asymptotes in the right place, and also that you've got these starting points in the right place. So even though there's no amplitude for the cosecant function, the amplitude of the sine function, so this number out here, does affect where you're going to start. It affects how far apart these starting places are between these pieces that are going down and the pieces that are going up, because it's going to affect the amplitude of this sine function that we graph in between here. All right, and so that's number 10.